Welcome to another edition of Math for No Reason. In this edition, we will be trying to prove this interesting assertion. From the integers 1 to 200, suppose we choose any 101 distinct integers. We have to show that among these 101 distinct integers, there would be two integers such that one of them is divisible by the other. To prove this, so let us suppose x1, x2, x101 be the chosen integers. Now we observe the following. So for any integer x which is positive, we can write x as 2 to the power k times a, where a is an odd integer. Let's see if we can quickly see this. So if x is odd, then we take k equal to 0 and then a is equal to x. If x is a multiple of 2 but not of 4, so x is multiple of 2 but not of 4, then we have x is equal to 2a or a is equal to x by 2. If x is a multiple of 4 but not of 8, then we can write x is equal to 2 square into a, or in other words a would be equal to x by 4, and so on. So we can always write any positive integer x as 2 to the power k times a, where a is an odd integer. Now let us apply this to the given integers x1, x2, x101. So we get x1 is equal to 2 to the power k1 into a1, x2 is 2 to the power k2 into a2, and so on. x101 is 2 to the power k101 into a101. Now note that all these integers a1, a2, a101 are odd integers. Now between 1 and 200, there are only 100 odd integers, 1, 3, 5, 7 up to 199. So between 1 to 200, there are only 100 odd integers. So therefore, two of these a1, a2, a101 must be same. This is basically an application of the pigeonhole principle. So we can write that by pigeonhole principle, there must be I not equal to j such that ai is equal to aj. Now consider xi, which is 2 to the power ki into ai, and xj, which is 2 to the power kj into aj. Since aj is equal to ai, so we have 2 to the power kj into ai. Now if ki is greater than kj, greater than equal to kj, then xi by xj, this quantity is 2 to the power ki minus kj. So therefore xj divides xi. In the other case, if kj is greater than ki, then xj by xi is 2 to the power kj minus ki, and in that case xi divides xj. So we see that the assertion that among the integers chosen there are two such that one of them is divisible by the other is true. This concludes the proof. Thank you.